So there's no point in having a model run for over a day and using the smallest amount of resources, but you also don't want it to run for 30 minutes or 20 minutes and then, pull everything in so that nothing else can run.
Let's talk a little bit about some of the challenges as a machine learning engineer. Now, it doesn't just have to be technical, it can be technical, but just maybe any stories or anything that comes to mind that you think would be interesting to talk about that you have experienced in the industry.
So my main experience with machine learning and big data and stuff has been with on-premise systems. On-premise systems, you are very limited to the resources available to you. Thankfully, the ones that I have worked on, it's rather big, so it puts the big in big data. But even then, it's not like that thing is changing over time. So when you are putting more and more stuff into production and having more and more success, the demand from business becomes more and more because they're like, oh, this is cool. These things are working. We want to do this now. We want to do this now. We want to do this now. So you keep moving more things into this cluster,
which is limited,
and it's limited. There is a cap to it. So the challenge that comes in with that is optimizing these processes to run with as little resources as possible, but also not take 10 hours.
Yes.
So there's no point in having a model run for over a day and using the smallest amount of resources. But you also don't want it to run for 30 minutes or 20 minutes and then, pull everything in so that nothing else can run. So
sure.
A lot of it's like going back to the dependencies that you mentioned. It's not just dependent on like its own data that's pulling in. In that environment, you are dependent on everything else that's running at that time. So that has definitely been the trickiest and most challenging aspect of working in that environment. But it's also been the most informative or learning
rewarding,
curve, because you have to get to know everything. You need to know what data you're working with, the size of the data set that you're working with, and then you need to know the size of the data set that you've created once you actually put that into a model. You need to know the type of joins, the type of aggregations, the type of language that you're using as well, like Manda or PySpark or like whatever you're using there. And then you also need to know timing. What else is going to be running at 3 a.m.? Like, you can't have it that everything runs at the same time. You need to spread it out, but then also need to get the results out in time. And so it's quite a few things that you need to keep track of when moving something into production and optimizing your process to then run at the best, to give the best results, but with the best resource usage as well.
That's interesting. And I'm also thinking probably, because it's one cluster or maybe like a limited set of resources, you have people doing development work and they don't want to necessarily wait 4 hours or whatever they need to wait for their thing to finish because they're still experimenting and they're still building. And there's that challenges of how do you overcome that with competing resources.
There's more and more data scientists, more and more data engineers, more and more people that have to come in and use this thing. So now them fighting with each other can also lead to dramatic messages going around.
That's fine.
Calling people out on how much they're using. That's always been fun. So, but I suppose it's similar with cloud because then you just get a personal message to say you used over $1,000 or something. So.
There's actually on that, there's a cloud story where I think there was a model or not a model, I think it's a data set that was built in a cloud platform, and there was a dashboard on top of this data set, and every time this dashboard anything was changed on it, like a filter or something like that, it would refresh, it would rerun the queries. And this was like, it's terabytes. So every time was like, okay, I think $1,000 or $2,000 every change. And they didn't pick it up, they picked it up a day later, and by that time, I think they racked up about $13,000, $14,000 just in one day. Now imagine they let that go and they didn't actually, I think it was a lot more. But anyway, I can't remember the exact figure.
If you don't check those things and you're just like, oh, it's working. It's working. We can put that into production. It's fine. It's fine.
And imagine they did. And then,
exactly.
And then over time, it'd go bad. But I think your experience in the on-prem world and how to optimize is super valuable, especially then in the cloud world as well.
Yeah, it's given me the respect for like resource usage and using the correct configurations and joining of data and anything, so no need to sit with a model that trains on 700 features, with millions or billions of rows, because now you're just throwing something at a wall hoping it will stick. You can actually look at the metrics, see feature importance, see like the parameters that you're using, scale it down. And
I almost mean to say, like, somebody coming in, just going to the cloud, they're going to be lazy in the sense where what you just mentioned, they're going to throw everything at it. It's going to be quick. It's going to be fun. It's going to be nice.
Yep. The results are going to be awesome.
Except the ball's going to rack up. But when you come in from a constrained environment, you already have all the experience and knowledge to be able to figure out, well, how do I get this a little bit better? How do I spend a little bit of time thinking about optimizing it such that I can then not spend so much money?